Today we're diving into, well, a really big story in modern astronomy. It's about discovery, loss, and how our picture of the solar system got completely redrawn.
Yeah, it's quite a saga. We're looking at it through the eyes of Mike Brown, the astronomer, who uh, kind of famously got nicknamed the Pluto Killer.
Right. And his personal story, his own accounts, they really capture the sheer drama of it all.
Absolutely. I mean, think about those 2 phone calls he made to his wife, Diane. They frame the whole thing perfectly.
The first one, that was about 18 months before the big decision. Pure excitement.
Frankly, I found a planet. That's what he said. He was talking about Eris, though they were calling it Xena back then. Just pure discovery joy.
But then fast forward to August 2006, right after the big IAU vote in Prague, another call to Diane.
And the mood is completely different. He just says Pluto is no longer a planet.
And her reaction just really, that sums up how pretty much everyone felt, didn't it?
It really does. So our mission today, you could say, is to unpack how we got to that moment. We'll look at the science, the history of defining planets, the massive effort hunting for these distant objects, and of course, that really controversial IAU decision.
Okay, let's start there then. Before Mike Brown even spots Eris, the whole idea of what a planet is, it was already a bit wobbly, wasn't it?
Oh, definitely. The foundations were shaky for a long time.
Why was that? What made the definition so, I guess, unstable?
Well, originally it wasn't very scientific. The word planet just comes from the Greek for wanderer.
Okay.
So for the ancient Greeks, that included the sun, the moon, Mercury, Venus, Mars, Jupiter, Saturn. Basically anything that moved against the background stars. It was descriptive, not, based on physical properties.
When did that simple idea start to cause problems?
The first big crisis really hit in the 19th century. Astronomers found Uranus, then Neptune, great successes. But then between Mars and Jupiter, they found Ceres in 1801.
And they called it a planet.
Yep, planet Ceres. Then came Pallas, Juno, Vesta, all hailed as new planets. We even named chemical elements after them, cerium, palladium. They were a big deal.
But the discoveries didn't stop there.
Exactly, that was the problem. They kept finding more and more little things in that same region. It wasn't just a few new planets. It was becoming clear it was a whole swarm of objects.
Like a belt of debris.
Pretty much.
Yeah.
And by the early 1900s, astronomers basically threw up their hands and said, okay, these aren't planets in the same way Jupiter or Mars are. They reclassified Ceres and the others as asteroids, or minor planets.
So that actually set a precedent, didn't it? The idea that being part of a big crowd, sharing your orbit, could cost you your planetary status.
Precisely. That was the key scientific concept that emerged. Planets were the big dominant objects, the whales of the solar system, gravitationally speaking. Asteroids were the minnows, part of a school. The sin, if you like, was being one of many in the same orbital space.
Which brings us back to Pluto, because even when it was found in 1930, it was different. It didn't quite fit with the others.
Right. It was always the oddball. Its orbit is much more stretched out, elliptical than the other planets.
And it's tilted, isn't it? Way off the main plane.
Yeah, by almost 20 degrees.
Yeah.
And crucially, its orbit actually crosses inside Neptune's path for part of its journey. So even from the start, it didn't look like the other 8. It was always classified a bit fragilely.
Okay, so the stage was set, scientifically speaking. Now let's get into the actual search. And Mike Brown's personal story. He had this background in Huntsville, Alabama.
Rocket City, yeah. Space was in the air there. But he tells this great story about when he was 15.
The Jupiter and Saturn thing.
He tracked them for months, just watching these 2 bright dots move slowly across the sky night after night. And he said that's when it clicked. They weren't just pictures on a poster. They were real places moving out there. It made the solar system tangible for him.
That's a powerful moment. But interestingly, when the first hints of the Kuiper Belt emerged in 1992,
with Jane Liu and David Jewett finding the first KBO, yeah.
Brown was a PhD student then, right? And he didn't immediately jump on it.
No, he admits he kind of dismissed it initially.
Yeah.
His focus was elsewhere, I think, on Jupiter and its moon Io. But later, as a young professor at Caltech, he realized just how little we knew about that whole region beyond Neptune, an unexplored frontier.
So he decided to look. And that first attempt sounds like incredibly hard work.
Oh, it was brutal. He used the big Palomar 48-inch Schmidt telescope, but with old-school photographic plates, glass plates, heavy.
Working in the dark, developing them, sounds painstaking.
Totally. He talks about riding this tiny, rickety elevator up to the telescope focus in pitch blackness. The plates gave a wide field of view, a big net, you could say, but they were slow, not very sensitive for really faint things, and just incredibly cumbersome to handle. That search went on for 3 years and found nothing major.
So the breakthrough needed better tech.
Exactly. The game changed when he switched to a modern digital camera, the CCD array. Now, interestingly, it actually covered less sky in one go, about 12 times less than the old plates.
Oh, really? That seems counterintuitive.
But it was something like 20 times faster and much, much more sensitive. It could pick up fainter objects much more quickly. So the efficiency just skyrocketed.
And that's when things started happening.
That's when the discoveries started rolling in. The technology finally matched the ambition.
First big one was Quaoar, right? 2002.
Yep. Quaoar.
Yeah.
Using the new digital system. It was big, maybe half the size of Pluto. Not a twin, but substantial.
And Brown called it an icy nail in the coffin for Pluto's planetary status. Why so definitive, then?
Because it wasn't just about size. It was proof that Pluto wasn't alone out there. Quaoar was clearly part of this larger population in the Kuiper Belt. It showed Pluto wasn't unique, it was just the first big KBO we'd found.
And the name, it was interesting too, wasn't it? Moving away from the usual Greek and Roman gods.
Right. They chose Quaoar from the mythology of the Tongva people, native to the Los Angeles area where Caltech is. It represented this powerful creation force. It felt like signaling a new era of understanding the outer solar system.
Okay, so Quaoar cracks the door open. Then comes Sedna in 2004. That one sounds even stranger.
Sedna was mind-blowing. Codenamed Dutch initially. It was detected because it was moving so incredibly slowly across the images.
Meaning it had to be really, really far away.
Extremely far. About twice as far as anything known in the solar system at that time, beyond the main Kuiper Belt. And its orbit was just wild. Hugely elongated. It takes something like 11,000 years to go around the sun once.
11,000 years? So where did it even come from?
Well, that's the thing. Brown and his colleagues realized it probably wasn't formed where it is now. Its orbit suggested it might be, as he put it, a fossil left over for the birth of the sun.
Wow. Like thrown outwards?
Possibly, yeah. Maybe by gravitational nudges from passing stars when the sun was still in its birth cluster billions of years ago. It's like a relic from the solar system's earliest infancy, preserved way out in the deep freeze.
Which fits the name they chose, Sedna, the Inuit goddess who lives in a cold, icy cave at the bottom of the ocean.
Exactly. A perfect name for such a cold, distant object.
Okay, Quaoar's Sedna. The picture is getting complicated. But then comes the discovery that really forces the issue. January 5th, 2005.
Eris. Though, as we said, they nicknamed it Xena for a long time after the TV warrior princess.
And right away, they knew it was significant.
Oh, yeah. Brown did the initial calculations. It was incredibly far out, around 120 astronomical units, so 3 times Pluto's average distance. But here's the kicker. It appeared brighter in their images than Pluto would look if you moved Pluto out to that same distance.
Which could only mean?
It had to be bigger than Pluto. Maybe significantly bigger.
Finding a 10th planet.
What?
Or something else.
Well, that was the question. And then they got spectra analyzing the light reflected off its surface. It showed a clear signature of frozen methane, just like Pluto.
So they weren't just similar in size, but in composition too. Twins, almost.
Exactly. 2 large icy bodies, both clearly belonging to this vast Kuiper Belt population. The scientific logic became unavoidable.
You couldn't call Pluto a planet and not call Eris a planet, especially if Eris was bigger.
Right. Or you had to reconsider Pluto's status altogether. It was the 19th century Ceres situation all over again, just much further out, and with much higher stakes, because Pluto was, Pluto. A beloved planet for 70-odd years.
It feels like the scientific conclusion was almost inevitable at that point.
From a purely classification standpoint, yes. Yeah. If you apply the historical precedent from the asteroids, finding a larger twin within the same swarm forces, a reevaluation.
Before we get to the IAU vote itself, there was another discovery around that time that caused a different kind of stir, Haumea.
Ah, yes, Haumea, initially nicknamed Santa because they found it around Christmas time. That one became controversial, but not really because of the science of the object itself.
It was about the discovery process.
Yeah. Brown's team had identified it, but they were doing their usual careful follow-up, checking data, writing papers. They typically waited sometimes up to 9 months before announcing things publicly.
Which sounds like standard scientific practice.
Yeah.
Verify first.
You think so. But a group of astronomers in Spain somehow accessed Brown's telescope observation logs, online logs, that weren't meant to be public, yet saw where his team had been pointing, looked at the same spot, found Haumea independently, and announced it immediately.
Oh, wow. That sounds ethically messy.
It got pretty heated. It forced Brown to publicly defend why his team didn't just announce discoveries instantly, like some amateur groups might demand.
What was his justification?
Pretty straightforward, really. Good science takes time. You need to be sure of your data, understand what you found. And, he argued, the immense effort and resources put into these deep sky surveys earns the discovery team the right to do that initial analysis and publish first. It's part of the reward for the hard work.
Makes sense. Okay, so all this Eris, the growing Kuiper Belt, the Haumea controversy all builds up to the IAU meeting in Prague in 2006. What was the atmosphere like?
Apparently it was intense. Astronomers were deeply divided. There were different proposals floating around. One, rather extreme one, suggested defining a planet simply based on being round due to gravity.
What would that have meant?
Well, suddenly you'd have potentially hundreds of planets. Ceres would be back, Eris would be in, Pluto obviously, but even Pluto's large moon Charon might qualify because the center of mass it shares with Pluto is actually outside Pluto itself. It would have been chaos.
So the keep Pluto and add loads more option, what was the alternative?
The main alternative was basically to draw a stricter line, leading to the 8-planet model we have now. It meant demoting Pluto.
And that debate must have been fierce. Science versus history, maybe even sentimentality?
Absolutely. People had grown up with 9 planets. Pluto was part of the cultural furniture. But in the end, the scientific arguments carried the day.
So the vote happened. What were the key resolutions?
The crucial one was Resolution 5A. It passed, and it laid out the 3 conditions an object needs to meet to be officially called a planet in our solar system.
Okay, what are they?
1, it has to orbit the sun. 2, it has to have enough mass for its own gravity to pull it into a nearly round-shaped hydrostatic equilibrium.
Pluto meets those two, right?
Yes. But then there's the third criterion, the killer one for Pluto. 3, it has to have cleared the neighborhood around its orbit.
Cleared the neighborhood. What does that mean in practice?
It means it has to be gravitationally dominant in its orbital zone. There can't be lots of other comparable objects sharing its space. It has to have either accreted most of the nearby material or flung it away.
And Pluto hasn't done that.
Nope. It lives right in the middle of the Kuiper Belt, a vast swarm of other icy bodies. It might be the biggest one we know of in that region, along with Eris, but it certainly hasn't cleared its neighborhood.
So it failed criterion number 3. And just like Ceres 150 years earlier, being part of a swarm meant reclassification.
Exactly. The IAU essentially recognized that the 1930 classification might have been a mistake, made before we understood the Kuiper Belt existed. Pluto wasn't demoted out of spite. It was reclassified based on our improved understanding of the solar system's structure. It became the prototype for a whole new category, dwarf planet.
And the naming of these new major dwarf planets really reflects the whole story, doesn't it?
Beautifully, yes. Eris, the object that sparked the whole crisis, the one bigger than Pluto, named after the Greek goddess of discord and strife, couldn't be more appropriate.
And its moon.
Its moon was named Dysnomia. She was Eris's daughter, the spirit of lawlessness or anarchy. But it was also a clever, affectionate nod from Mike Brown to his wife, Diane, because Lucy Lawless played Xena on TV.
Huh, that's great. What about the others?
Make, the one nicknamed Easter Bunny, was named for the creator god of the Rapa Nui people of Easter Island. And Haumea, the controversial Santa, got its name from the Hawaiian goddess of childbirth and fertility.
Why childbirth for Haumea?
Because Haumea is very weirdly shaped, like a squashed American football.
Right.
And it spins incredibly fast. It also has 2 small moons. The thinking is that it suffered a massive collision in the past, which spun it up and knocked off fragments that became its moons, almost like children broken off from the parent body. So the name fits its suspected history.
So looking back at this whole deep dive, what's the big takeaway?
I think it's that these discoveries, especially Eris, forced astronomers to finally get serious and consistent about classifying objects in the solar system. We moved from a kind of historical list to a system based on physical properties and orbital dynamics.
Leading to this clearer picture.
Yeah, a much more organized view. You've got the 4 inner rocky terrestrial planets, then the 4 outer gas and ice giants. Then you have the 2 great swarms, the asteroid belt between Mars and Jupiter, and the Kuiper Belt beyond Neptune.
And Pluto, Eris, Ceres, Haumea, Make, they're the largest known members of those swarms, dwarf planet.
Exactly. Classified with their belts, just as Ceres was eventually classified with the asteroids, it brings a certain scientific coherence to the whole system.
But the story isn't quite over, is it? Mike Brown is still searching.
That's right. He hasn't stopped looking. He still hopes to find something truly massive out there, maybe something the size of Mars or even Earth.
A potential Planet 9.
A real Planet 9, perhaps. Something that's clearly not part of the Kuiper Belt swarm. Something that truly dominates its own vast orbit far beyond Neptune.
And if he or someone else actually finds an object like that, a Mars-sized body way out there.
Well, that would definitely reopen the debate, wouldn't it? It would force everyone to look at that third criterion, clearing the neighborhood again.
So here's a final thought for you listening. If that third rule, gravitational dominance, is key, what would it take for you? If we found a new object out there, how big or how alone in its orbit would it need to be for you to say, yes, that is the ninth planet?
Definitely something to ponder next time you're looking up at the stars.